Hello, I'm Mauro Lepore. Today I'm going to talk about unit testing following some of the slides from a lesson delivered by Hadley Wickham and RStudio in a recent workshop called Tidy Tools. The workshop was based on a little package that Hadley developed for us, and that package contained a function called addCall, which, as you can see here, takes a data frame, the name of a new column that you want to add to that data frame, and the value of that column, and basically which position of the data frame you would want to add that column in. So we're going to use this idea and develop it in an example. Indeed, what we are going to be working with is another function that is called addCalls, which instead of doing this, what it does is it inserts an entire data frame between any column of this or that first data frame. I'm going to show that in an example in a moment. Basically, to get an idea visually of what we want to do is given a data frame with columns X, Y, Z, and positions 1 would be to the very far left of the data frame. So if we inserted a new data frame here in position 1, all the columns from that new data frame would come here. If we inserted in position 2, then we would have first the column from data frame 1, then all the columns from data frame 2, and then YZ from data frame 1 again. So what we're going to do is to create a package to show that, and I'm going to copy this code because this is the function we are going to be working with. So let's jump to RStudio, and I'm going to here paste that code, but I'm going to keep it just here on my clipboard. I'm going to copy it. So I'm going to run now here is this first line, so not the second one, so I'm going to remove it for clarity. This first line and the directory where I'm going to create my package is going to be my home directory, and I'm going to call this package addCall. I'm going to use, as you can see here, the function use this create package. So let's go ahead and run that. Now I'll be jumping to that package. You can see here is where we are, and the first thing I'm going to do is to run so we already did this, so I'm going to run this function which creates an R file inside the R folder and names the file addCalls. So there we go, we have an empty file now, but I'm going to copy all this code and paste it in the new file. So there we go. So now we have a function called addCalls, which lives here in R in the package addCall. That's all right. So what we are going to do next is to think a little about what is the workflow that we generally use in the package and how that compares to the workflow we are going to see today. Generally, you write R code and you load that code with Command or Control plus Shift plus L, which is a shortcut for the function DevTools load all. And once you have that code loaded in your R session, you can start explore that code on the console. But that is error prone and doesn't scale up very well. So once you have built a package with many functions, you cannot check every single one again and again on the console to see if they are doing what they should be doing. So instead, it's much better to develop a workflow where you use tests to check that your functions do what they should. So basically you write our code and then you run all the tests that verify or not that those functions do what they should. So the function that does that runs your tests is the function DevTools test, and you can run it with the keyboard shortcut Command or Control plus Shift plus T. So I'm going to show that, but before I can do that, I'm going to use to write some tests. So the tests were given in the class by Hadley already, but you could create your own. So here is the function we used, and what we want to do is to create a file that will host the tests related to this function. So the best and quickest way to do this is to use the function use test, because this function will, even if we don't give it any argument here, if we have open a file, an R file that contains the functions we want to test, the function use test will create a file that has exactly that same name and in the right place. Before I run enter here, I'm going to show you the home directory. So you can see that I have no other folders other than man and R. So when I run now this code, this will create a folder called tests, and inside tests there is a folder called test.dat, and there is the new file that has just opened here. This file opens with a dummy test for us to run, but we're going to remove it and instead paste the code that Hadley provided in the class. So you can see what this test is doing. So it creates a data frame number 1, then a data frame number 2, and what it does is it runs the function add calls for with the input data frame 1, data frame 2, add position, whatever. So with this little helper function, we can now run a number of expectations in a very kind of succinct way, where we say at position 1, run the function add calls. At position 2, run the function add calls, and so on, all the way up to position 4. So data frame 1 has columns A, B, C, and data frame 2 has columns capital X, capital Y. So the expectation is that the output of add pos will be, if it's position 1, then what we'll get is first the 2 columns that come from data frame 2, and then all the remaining columns from data frame 1. If we asked add calls to insert the data frame at position 2, then we would have first 1 column from data frame 1, then in position 2 all the columns from data frame 2, and then the remaining columns from data frame 1 again, and so on and so forth. So let's go ahead and practice the workflow that we have just discussed. So the workflow that includes no test was Shift-Control-L to run the function DevTools load all. But now we have this new workflow where we can press Shift-Control-T, and as you can see, that runs the function DevTools test, and we have here some information that is very useful. So there is a number of the number of tests that were run are 4, 1 for each of these expectations here, and everything has passed. If I broke this test, I say that this test expects column name set, and there is no column set in data frame 2, sorry, then this test should fail. So let's go ahead and verify that with Shift-Control-T. There you go. There is 3 passing tests and 1 failing test. I'm going to revert that so that passes again, and I can also break the function, which is the most common scenario, where you could be developing this function further and eventually you do something silly, say return null. So this function now is completely broken, returns null all the time. So if I run the tests, all the tests should fail, and there you see. So it is a very good idea to break your tests to verify that they are doing what they should be doing. Good. So let's go back to the slides. So because you have this safety net, you have this test that will let you know if something is going wrong with your function, then you have the confidence to build a better interface for your function and to refactor the internals of the function to make it more clear or to make it more expressive. So that certainly will improve the readability and the performance of your function if that's what you wish, without with the safety net of knowing that that won't change the behavior of your function, and if it does, then you will get a failing test and you will know why. This is also a good framework to know when to stop, basically, because if you have organized your work around tests that should pass, once all the tests pass, then you're done. And if you haven't finished for the day, then you can leave failing tests, and very easily the following day you will know where to restart your work. The test will not only tell you that something is wrong, but it will also tell you exactly where that problem is. So there are a number of functions in the test that package, which is the one that contains the functions like expect equal, expect error, and many others. But these two, expect equal and expect error, are the ones that cover most of the cases that you would need. But still, it's a very good idea for you to go and check this link for a comprehensive list of functions, including the test that package, so that you know what you can do with it. To write robust code, you would want your functions to very quickly reject a bad input. So the scenario that you would want to be is this one here, where, for example, if a user provides bad input, immediately your function runs an assertion and outputs the text, that assertion detects the bad input and immediately outputs an error message that says, no, something is wrong here, and the user knows how to fix it. The bad scenario could be where the input does not get caught in your function, the first one receiving the input, but instead goes through a series of other functions related that your function calls. But eventually, when something goes so wrong that an error is thrown to the user, the function that returns the error is so far away from the function the user called that the message is almost certainly not informative or very hard to understand. So your work as a developer is to write assertions that detect those bad inputs. For example, one very common function for that could be stop if not. Imagine that you need a data frame as the first input of your function, so you can check with stop if not, and then is data frame and the name of the object that is the first input of your function. You could check if your user has provided a data frame, and if it's not a data frame, then stop if not will immediately throw an error. So we have kind of touched on this idea that tests can basically help you build a workflow where you can even start writing your tests before you write the code. And that's a good idea, because with the tests, what you build is kind of a roadmap of where you should kind of be at different points along your development. So if you can start easily, you can start with a number of tests that you want your function to pass even before you write your function. And then as you work, you complete each of those steps that you need to do to build your function, and as a consequence, each of the originally failing tests will start to pass. So when you have achieved making all the tests to pass, then you will have finished your work. The workflow is then the test-driven development. Then is write first your tests, then write the code that makes the tests to pass, and run all the tests automatically. So the last resource I'm going to show is how to check how much coverage, how much of your code is covered by tests. So we are going to use the function package coverage and wrap it around the function report from the package cover. So I'm going here on the console to paste that code. So what this will do is will produce a nice kind of HTML file that will tell me how much of my code is covered by some tests. Here is 100% because we have only one function. That was easy. And here we can see all the lines of code that are covered. That's the end of the presentation. Before I go, I wanted to remind you that this was a presentation by Hadley Wickham, delivered in the Tidy Tools workshop, and the license for this material means that it is okay to share, so feel free to share.